Hello everyone, welcome to a brand new lecture on retrieval augmented generation. RAG, as in the name suggests, it's retrieving a particular information in an augmented scenario. When I say augmented scenario, it's basically construct on the retrieved information. So talking about RAG a bit more and different components, RAG is basically having two main key components. One is your retrieval model and another one is your language model. A retrieval model is where it fetches relevant information from an external source, which could be a database or a search engine or any other information repository. And the language model is one that generates responses based on the retrieved knowledge. Because retrieved knowledge could be in a form of a dictionary where there is a key value pair where key is your retrieved information in words and value could be the score for that particular retrieved information. So talking about the different components, I would like to just quickly hover on to the different components that come into the sequence. So one is basically the user puts in the query, right? User can ask that tell me about five different properties of a cat, or user can ask what is a small language model, tell me about a small language model, tell me about Prime Minister Narendra Modi, tell me about who built Taj Mahal. All these things are there. So the language, the retrieval model, where does it goes? How does it knows who built Taj Mahal? How does it knows whether a cat is an animal or a bird? So for this, it needs a knowledge base. That is where the retrieval part comes into. It will go and look into its knowledge base, make a search over the domain specific data set, find out the most similar items, most similar knowledge using mathematical metric called as cosine similarity, that is on vectors, which we will talk about in the hands-on. So when it fetches the most relevant information, it passes on to your language model. The language model basically generates your response based on the retrieved knowledge and sends it back to the response. So 1, 2, 3, 4, and 5. Now, before we dive in deep, just talking about this particular pre-training. So the language model is basically a pre-trained language model, which is publicly available. You guys must be familiar with ChatGPT 3, ChatGPT 5, Llama 5.2, and multiple other that are provided by the Microsoft, Google, Meta, or Hugging Face, and they are all available on Hugging Face via Transformers library. Right. So now talking about creation of a particular knowledge base could be through different data sources, such as it could be an Azure SQL database, or it could be a PDF file, it could be an Excel file, it could be an image, video. So you need to do some kind of your machine vision or deep learning techniques on top of your provided data set to extract their relevant content information, put it in a vector DB, which will serve as the knowledge base for your RAG system. Now moving on to the next page where we talk about in a bit deep. So this is the data preparation that I was talking about. We are also doing something similar. We are going to look onto two scenarios and we are going to combine both the data sources. So one of the data sources is basically cat's fact data source, which I can quickly show you over here. So here we have a txt file which has a lot much of information about cat, that the group of birds associated with that, and approximately 40,000 people are bitten by cats in the US annually. A group of cats is called as a clouder. Technical term for cat's hairball is a bezoar. Or in reply, God made the lion sneeze and out popped the cat. So this is one big corpus where it's all talking about cat as an animal, and then I have another big corpus where it's a research paper. The research paper termed as small language models are the future of agentic AI, right? So we are going to combine both of these data sets into one big knowledge source, which is exactly what we do as creating as a database, right? Before even you create a database, there are two primary requirements that you should do. One is creating an embedding, and before creating embedding, you should do a chunking on your document. So when we combine both of the text files, we basically perform a chunking. A chunking is basically breaking down your document or breaking down your sentence into different chunks, which will be used by a embedding model to create a numerical representation of your document against different properties. Right? That is what is a vector embedding, which I'll show you through a graphical representation as well. And once we have the vector embedding handy, since the vector embedding is a very large numerical representation, it's a very big matrix, you cannot do a for loop, a simple Pythonic for loop, right? So we save it as a PKL file. Saving it as a PKL file gives us the accessibility to access that particular vector embedding any place, anywhere, anytime, right? So it's just not you create a vector embedding which is vector db. You can even create a graph db, which will be called as a graph rag or a hybrid rag and a hierarchical rag, which we can discuss in the next lecture. Now, once you have the vector DB, what do? Right? Do you end over there? No, that is not even the first step. The first step is to basically set up a retrieval model and a language model. A retrieval part is this one, right? Which we are talking about. The query, the embedding, the vector DB. So user inputs a query, user asks, what, tell me 5 facts about cats. What does the embedding do? It basically breaks down your sentence into tell me 5 facts about cat into 6 different words, generates a vector embedding for your 6 words, and then takes that vector embedding, takes the created vector embedding which is created over your corpus, performs a cosine similarity between both multiple vectors, and then finds out the top 5 facts and retrieves that to your language model. Now language, this is exactly where your language model will come into picture, that the relevant data that it has retrieved, right? For example, cats, let's say what we read about just right in the text file, right? That the group of cats is basically called as a is called as a clouder. This could be one of the fact as well. So this will also be returned, right? And each of the fact will have some high score. And since we will only look at top 3 or top 5 return chunks or return documents, that is what the language model is going to take in, sugarcoat it, and send it back. Right. So simple. Before we go into hands-on, two quick things which is not on the screen, but if you listen to me, the one thing is, why do we need a rag? Why do we need a rag? Right? You can search who made Taj Mahal. You can search who is the Prime Minister of India. You can search what are the tariff war that the Trump has initiated, right? Because these are globally available topics. What is not a globally available topic, right? For example, what is your address? Which company do you work in? Your resume is not a globally your is not a publicly available document. Whatever is not a publicly available document is something on which you can build a rag. For example, I am building on cat facts and I am building on a small language model research paper. I can build a rag on a collection of resumes that I get for referral purpose as well. Or I can even build on the corpus of the organizational documents that I have. And that is exactly where the organizations are heading. In fact, they are trying to cumulate all such relevant documents into a one vector DB and then index over that vector DB. Some projects are using a rag, some projects are just using searching, right? Searching is basically indexing that what is you get over your vector DB. So this is exactly where RAG stands. RAG is something that you can train specifically for your purpose, whereas ChatGPT and publicly available scenarios are all on your publicly available dataset. Now, second thing is basically we are using Llama as our Pythonic library. To do that, I tried with Hugging Face, PyTorch, but there were just some versioning problems between all the three libraries, and Llama is just so sweet. You just install it and it starts getting done, right? So okay, now let's dive into the hands-on. As I've already told you, we are building basically to on cats facts data and small language model research paper. What do we do is basically we look into our data folder, we find in all the txt files, and we basically create a one big corpus, right? Now if I load this, you can see 582404 entries. That means 58,204 sentences I totally have. Just look at the first some thousand words. We get to see, okay, this is a small language model, feature of agentic AI, string is a mass, SLM mass sufficiently powerful, inherently more suitable, and blah 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 blah. Now our data set is ready, but as I told you, right, dataset is ready up till over here. We are yet to do chunking, and we are yet to do embedding, vector embedding. So before we do chunking and vector embedding, I would like to explain quickly what is a vector embedding and how does the fetching of the I mean what is a vector embedding, and then what is chunking, and then how we do fetching of the particular retrieval from your vector DB. So vector embeddings is basically your numerical representation of the whole input sentence, which is going to basically something like this. In agentic system, there are, so it's going to break into the future of the agentic AI, right? So let's take this, the future of agentic AI. Here you can see it's cats, puppy, houses, apple, baby. If you look at this example, let's say you get a sentence called as my baby's name is XYZ. So your baby's name, baby as a word, will always be either a newborn or a human. Your baby is not an animal, right? So the score associated for your particular word, baby, against different properties, animal, newborn, human, wood, metal, road, car, truck, there would be multiple scores for that particular word. And this is all represented in a numerical matrix structure. That's why I am calling it multiple times numerical representation of your words against their properties. Number of dimensions is basically called as your properties. Now, if you just look at this particular highlighted section, which is the future of agentic AI, if you try to interpret in terms of embeddings, each of the future of agentic AI is broken into 5 different words. And let's just pick up one of the word, which is basically AI. It can never be an animal. It can never be a newborn. It can never be a human. But it can be a machine, right? So for there, it will be a high score against that particular word. Similarly, if we have AI computers or binary, or if a property is there, let's say singular or plural, right? So similarly scores for that particular word will be there. If we take in the current level of capabilities, right? So current, if you put it against electricity, it will be very high. But if you put it against a particular let's say tense, for example past or present, right, or future. So if you take these three tenses, past will be have a less score, but present and current would be having a very high score, and future would be having a less score. Similarly, level against different level of floors and things like that, right? So this whole document is going to get chunked, then put into big numerical representation against properties. uh, this is very important because it helps the machine understand what is the context of the incoming word against the provided input query. Now talking about the text chunk is basically you have a document where we had 58,204 sentences. We are going to break it down. We are going to consider each of our sentence into a one big text chunk, which we are going to store into our vector index using an embedding model. The embedding model that we are using are the embedding model and the language model are both from Llama. You can find more details about these. What do? We do is basically we create a list and then we just pass it through the embedding model, each of the chunk, and chunk is basically the I mean we will call it against the database, which is for I comma chunk. And if I just run this, and I will just quickly show you what it does is basically it will, so you can see 58,204, it is creating one big vector database where it's going, if it is adding each line by line into the sentence. Let me just break this. So since it takes some time, it takes somewhere around 15 minutes to just do this. What I did is basically I kept it as in handy as in vectordb.pkl. I've already stored it. Now once my vectordb is set, I have reached to this particular point where I have my data corpus set up. Now what I'm going to do, I'm going to set up my retrieval part. Retrieval part is basically where I'm going to get a particular input query from the user. I'm going to set an embedding over here and I'm going to perform. So setting an embedding is something that we do later, where we ask for a retrieval. For that retrieval, we use a cosine similarity, right? So what is a cosine similarity? It's basically it's a distance metric, to be precise, and it takes in two vectors, calculates their difference in distance, which is basically cosine distance. And if it says that if the two vectors are near, that means they are much more relevant with respect to their semantic context or just simple context, right? For example, if I just go up over here, if you get a bird called as a baby, and if it is evaluated against newborn and human will have a much more closer cosine similarity metric that would be returned back, right? So we set up the cosine similarity, and this cosine similarity is what we get in our retrieval, right? So this is one of the helper functions. What do we do in retrieval? We are basically creating this embedding model on the input query, right? If you look at this particular piece of code, this is exactly what we have already done over here. So you just changed an input chunk over here where, so this line is basically doing and performing an embedding computation over your provided dataset corpus, and here you are doing the same thing over provided your input query, right? And this is what your query embedding is basically go inside your cosine similarity, and here it's going to perform a matching between both of your query embedding and your normal embedding as well. And then you get some similarities against chunk and similarity, and then I'm going to just sort that so that I get the highest similarities, and I'm going to return top three similar scenarios. Now let's quickly run that particular chatbot to see. This is a very handy Pythonic code. I would suggest could just clone the repo and start using it. So I will just ask, right? We were talking about what are 5 facts about cats. And if I run this, it has broken my whole input sentence into an embedding, query embedding, and I already have an embedding, and this retrieve is what I am calling over here. It's taking user input, and embedding is basically my vectordb.pkl. So now it's performing similarity, and you can see here I get it. Yeah, perfect. Voila. Here are the 5 interesting facts about the cats. A group of a cat is called as a clouder. Wow, I'm so lucky. We were just discussing about this as one of the fact, and we have got that. Domestic cats are the only species that can reproduce. Cats have 3 eyelids, an upper eyelid, lower eyelid, third eyelid. Okay, never. I never noticed that. Cats can't taste sweetness because they lack the receptors of the sugar. Okay. Now let's ask about, tell me about small language model. Let's see, because I have fed in my uh, small language model as the future of agentic AI research paper as well, right? So it should tell me some of the details at least. Oh wow. Okay. Small language models are type of artificial that can learn and mimic certain parameter patterns or functions similar to how humans do. They typically consist of simple neural network architecture. Okay. Here's what you know so far. Small language have limited capacity for storing and processing large amounts of data. Agreed. They are often used for tasks that involve generation text responses such as chatbot. Correct. We have actually created a small language model only. The capacity, not exactly, but small language model RAG, SL RAG, I can call it, small language RAG. The complexity of the task or the function being modeled can depend on specific language model. Yeah, so this is good. And yep, I think this is a very concise way in which you can build your own RAG system. I would go ahead and create one which is basically going to be a corpus of different resumes to find out what is the hot skills that are going in agentic AI. Again, Thank you for watching this video and stay safe. Take care. Thank you, everyone.